Okay, this is the second video in a series of videos describing to you how you deal with regions of space questions. I'm going to get straight into some basic examples here. So on the board I've got two given inequalities which I need to represent as a region of space diagram. Okay, as you can see for the first one we've got -3 less than or equal to x less than or equal to 2. Basically that means that in our graph that we're going to draw we need to show all the places which have x values or x coordinates if you like which lie between -3 and 2. So I'm going to set up a reasonably accurate picture for this. Again, it's not just a sketch, I am going to do things quite accurately. I'm going to do an x-axis that goes 0, 1, 2, and I'm going to go down -1, -2, -3, like so. And in the same sort of way as I did in the previous video, I'm now going to say the x values need to lie between -3 and 2. So you need to go to -3 on the x-axis, and you need to draw a vertical line, excuse me, like so. And this vertical line that I'm drawing needs to be a solid line because you can see that we have equality symbols in the given inequality. Now that line there sees all the x values that lie for all points on it, lying on it, will be equal to -3. And likewise we've got a 2 there, so I need to draw a vertical line at 2 on the x-axis like so. All points on there will have x values equal to 2. Now what we need to show is all the x values, all the places which have got x values which lie between -3 and 2 using this double inequality notation. So that basically means all the points that lie in between those two lines. And the lines themselves are solid because of the equality symbols as I mentioned earlier. So we need to put little arrows that are pointing like so on these two boundary lines. So the region of space we're talking about must be this middle section here. We also, however, have got a second double inequality region of space. And this is that y values must lie between 1 and 3. So what I need to do now is to, on the y-axis, indicate 1, 2 and 3. And the y values must lie between 1 and 3. Now be careful, y values being between 1 and 3 means I'm going to have two horizontal lines at 1 and 3 and the region lies in between them. But if you look at the inequality notation here, 1 is less than y, which means I do not have for the 1 boundary on the y-axis a solid line. It must be dotted. So I have a dotted horizontal line like so. That is y equals 1. And we have the other boundary, y equals 3. Now that is solid because there is an equality symbol there. So y can actually equal to 3. So we have those boundary lines like so. So this inequality represents all the points that have y coordinates lying between 1 and 3. Well, that's all the points between those two horizontal lines, this region here. So I'm going to put little arrows pointing up, like so, above that line, and it must be below that line. So this region sandwiched between those two horizontal lines, this region here, must be the region that obeys those conditions. Right, now, we need to shade the region in that obeys all conditions. They must be between these two vertical lines and between the two horizontal lines I've just drawn. And if you think about it, the region that I'm talking about, it must be this region of the picture, like so. Anywhere in that central rectangle obeys all 4 of those conditions. In between those two lines vertical, in between the two horizontal lines. And that is the first question on this video. Fairly straightforward because all lines are either horizontal or vertical. Okay, so what I'm going to do now for the second question is introduce some diagonal boundary lines where things get a little bit more difficult. So if I get rid of that and I talk about now question 2. Now question 2 is going to have the following. inequalities that the region must satisfy. So first of all, I'm going to say x is bigger than minus 2. Okay, that's going to be straightforward because that is going to be just a boundary x equals minus 2, and it'll be drawn in dots because there's no equality symbol there. The second boundary line is going to be y is less than 4. Once again, that will be simple, and that boundary is y equals 4, and it will be drawn once again in dots. And then we're going to have a third boundary line. Now this is going to be slightly different. This third boundary line is going to be a diagonal line, and I'm going to give you the name or the equation of the inequality that we're talking about. So it's going to be y is greater than x plus 1. Okay, so when I now come to draw this boundary line, it's really simple. All you do is you change the inequality symbol to an equal sign, and we're going to draw the boundary y equals x plus 1, and it will be in dots because there's no equality symbol as part of that inequality there. So okay, I am now going to do this fairly accurately. During the course of this video, the next few examples I may do just as sketches, but for this one I will do it quite accurately. So I'm going to set up a y-axis. I'm going to set up an x-axis, like so. I'm going to mark on 1, 2, 3, minus 1, minus 2, and minus 3. And then the x numbers, 1, 2, 3, and 4. And what I'm going to do is plot the first two boundary lines. So x equals minus 2, dotted because there's no equal sign there. So I go to x, I go to minus 2, and I draw a vertical dotted line. That boundary is x equals minus 2. Every point on that line has an x coordinate equals minus 2. What I need to show is all the places with x coordinates bigger than minus 2. So I need to draw arrows going to the right. So everywhere to the right is going to satisfy that starting condition. Okay, the second one, y less than 4, I draw the boundary y equals 4. So you go to 4 on the y-axis. Once again, no inequality symbol, sorry, no equals symbol, no equals symbol. So I need to draw a horizontal dotted line. That's y equals 4. And I need to show all the places y less than 4, means I need to put arrows going down. Anywhere below that will have y values less than 4. So that's two boundaries taken care of. Now I come on to the third one, and this one is going to be a diagonal boundary. And I need to draw the boundary line itself as y equals x plus 1. Now that is the typical name or equation of a straight line which has got a certain slope. If it's an accurate picture that I'm drawing, I need to get some accurate points to plot to draw that boundary line. So what I'm going to do for this one is actually set up a little table of values, x and y, and I'm going to work out, I think I'll work out 3 points for this. Obviously, because it's a straight line, you could get away with working out just 2 points and join them up and you've got your line. There again, I could also draw a table of values with 4, 5 or 6 points. I'm going to use 3 points. If you're given a choice, I would suggest something like 3 points would be fine. It's not wrong to use 2 points, but I'm going to use 3. Also, I'm going to pick my own x coordinates. You probably won't be told what x values to pick. So I'm going to pick nice easy ones. 0, 1, 2. It's my choice, make it easy. And therefore, the y values to go with these come from the name of this boundary line, the equation of the boundary line. So the y value will be the x value plus 1. So if x is 0, you're going to get 0 plus 1, that's 1. If x is 1, the y value to go with it will be 1 plus 1, that's 2. X is 2, y will be 2 plus 1, that's 3. So we have got 3 points which we can now plot and join up to get our diagonal boundary line. So, 0, 1. So in the picture, 0 on the x is there and 1 is there. Next, 1, 2. 1 across, 2 up is there. Next, 2, 3. That's 2 across, 3 up, that's there. Get yourself a straight edge and draw a diagonal line joining those points. Look at this here, there is no equality symbol, so it must be drawn in dots. So something like this is what we're getting, in dots, like so. Obviously you'd use a ruler and extend it across your page, like so. And before you forget it, you need to label this. Y equals x plus 1 is the boundary line itself. Now what you need to do is realise that everywhere on that dotted line, the coordinates will obey their y value being equal to the x value plus 1. But I don't want to show that. I want to show all the places where the y coordinate is bigger than the x coordinate plus 1. Now it's really simple. If it's a bigger than, then the place that you need to be showing as a region is going to be simply, if that's the line, everywhere above the line you will find the y coordinate is going to be bigger than the x coordinate plus 1. Everywhere below the line, well, the y coordinates will be less than the x coordinates plus 1. So in my picture here, I'm going to put arrows which are going like so above the line, like so, the top left hand part of the picture. So what I've got now to obey all three conditions is to find the region in the picture which does that. So looking at that, it's got to be above that diagonal line, it's got to be below that horizontal line, it's got to be to the right of that vertical line. I think the region, I'll show you this in a green, that we need to look at is this central triangle that I'm now currently shading in. And I think that there will satisfy all three conditions. This central triangle is above that, below that, and to the right of that. Okay, so there you go. There's a slightly more advanced question on regions of space. The diagonal line has been introduced, and I've used a table of values to work out the points to obtain the boundary line. So, slightly harder, that was question number 2. For question number 3, I'll make things even harder. So if I make some space, so for question number 3, I'm going to look at this set of inequalities that I have to satisfy. So the first inequality I want us to look at is x greater than or equal to minus 4. And then the second boundary line is going to be y is greater than minus x minus 1. And the third boundary line is going to be y is less than or equal to, so that will be a solid line when I come to draw the thing, and it's going to be y is less than or equal to 2x's plus 3. So I want to shade the region which obeys all three of those conditions. The second two, as you can see, when I write the actual boundary itself as y equals minus x minus 1 and y equals 2x plus 3, these two are typical equations or names of diagonal straight lines. So there's two diagonal straight line boundaries in this particular question. The first one is a very straightforward x equals minus 4 boundary, which will be a vertical straight line. Okay, I think I'll do another accurate picture for you in this particular one. I won't do a sketch for this one. And so what I'm going to do is set up axes that are going to be used to draw this situation. And I'm going to do x values, 1, 2, 3, 4, 0. I'm going to go down minus 1, minus 2, minus 3 and minus 4. And just based on that I can plot the first boundary line, which is x equals minus 4. There is an equality there, so it needs to be solid. So I go to minus 4 on the x-axis, I go to minus 4 there, and I draw a solid vertical line, and I label it x equals minus 4. Everywhere on that line, every point on that line has an x value equal to minus 4. I need to show all the places x bigger than or equal to minus 4. So I need to go right of that. Everywhere to the right, the x coordinates are bigger than minus 4. Okay, so that's done the straightforward vertical line boundary. I now need to look at the two diagonal line boundaries which have these equations. Well, I need to do some accurate point plotting here, so I need some tables of values. So what I'm going to do, I'll do the calculation for the tables because I'm not sure I've got enough space over there for these two lines. So, for y equals minus x minus 1. Okay, a table of values, x and y, like so, and I'm going to work out 3 points. Okay, so from the equation, from the name, the 3 points I'm going to pick, 0, 1 and 2. If x is 0, the y value from the name will be minus nothing. Well, that's nothing. Take away 1. That's minus 1. So there's the first point. If x is 1, I'm going to get y equals minus 1, take away 1. Minus 1, take away 1, you get minus 2. And then the third one, if x is 2, you get y equals minus 2, take away 1, that's minus 3. So I've got 3 points to plot. Let's plot them. Okay, I need to draw my y-scale in to be able to plot them. So my y-scale is 0, minus 1, minus 2, minus 3, like so. That's enough to be able to plot these. So 0 minus 1 is there on the y-axis. 1 minus 2 is about there. And then 2 minus 3 is 2 across, 3 down. We have that. Now remember, for this first boundary line that I'm drawing, there's no equality, so it must be in dots. So I need to do a dotted line through those 3 points, across your page, and carry it on over here. Everywhere on that line, the y values are equal to minus the x value minus 1. I need to show the places which are bigger than minus x minus 1. So that means the arrows must go above that line, not below it. So above. So arrows are going this way. Okay, we get the line going into the calculation there because I haven't got much space, but I think you get the idea. So there is the second boundary line with the actual arrows showing direction. I'm going to get rid of that to clarify the picture. I need to do a third boundary, which is y equals 2x plus 3 now. It's going to be a solid line because there is equals there, and I am going to do a table of values. I'll do the table for this one here in this little space here. You obviously have more space when you tackle these on the exam paper, so you organise your space a bit more effectively than I have got here because I don't want to go off screen with the calculation. So I'm going to pick x values 0, 1 and 2 again. Get 3 points to plot for this boundary. If x is 0, y will be 2 noughts, that's nothing, add 3, 3. If x is 1, y will be 2 ones are 2, add 3, that's 5. And if x is 2, y will be 2 2s are 4, add 3, that's 7. So for this boundary line I've got 3 points to plot. So let's plot them. 0, 3. So that's 0 on the x, and now I need to go up 1, 2, 3 on my y scale. I need to plot 0, 3. There it is. I now need to plot 1, 5. Okay, so I need to carry on this 4 and 5 to be able to plot my picture. So 1, 5 is 1 across and 5 up, and that is there. Now, I also, if I'm going to use this point 2, 7, need to go 2 across and 7 up. Well, it's gone off the scale that I'm using. So because that was my choice, I'm deciding I'm not going to bother plotting that one. 2 points I've got, and 2 points is all I need to draw the straight line. So that's what I'm going to use. I won't bother with 2, 7 because it goes off my scale. Okay, so fine. Let's now join up those 2 points with a solid line to get your new boundary line. Now obviously you'd be using a ruler but you're going to get a straight line looking like that. And you need to label the straight line with its equation. So its equation is y equals 2x's plus 3. Everywhere on that straight line have points which obey y coordinate equaling 2 times the x coordinate plus 3. I need the y coordinates to be less than or equal to 2 times the x coordinate plus 3. Well, less than is implying underneath that line. So we need arrows going underneath, going underneath, going underneath, going underneath. So, where do we now need to shade in? We have got 3 conditions based on 3 straight lines with information. We have got a vertical line there. We need to be to the right of that. We have a dotted line there. We need to be above that. We have a solid line diagonally like so. We need to be below that. Well, if you think about it, I'll get a green. I need to shade in this region. I am now shading in green to obey those conditions, like so. That green region there is below that diagonal, above that diagonal, and it does obey to the right of that as well. If you think about it, in this particular example, this vertical line here is actually redundant. It doesn't affect the picture. So if I didn't put in that first inequality at all, and I did not actually draw that, we'd still end up with the same region of space. Most questions that you get set, if they give you an inequality, it will have an impact upon the picture that you shade. Okay? But in this case it didn't. Fine, that's the end of this question. And for the time being, that's as far as I'm going to take it in this video. In the next video, I'm going to make things a little bit more confusing. But if you follow some basic principles that we've talked about in the past, you'll find them very straightforward. That's the end of this video.